A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in our today's online session of Applied Physics, lecture number 6. Hope you all are fine and having good health. We start today's session with the verses of Holy Quran. So, for the sake of thing, I am sharing my screen with you guys. Further, we are moving towards today's lecture on the topic electric field intensity, or we can say the electric field. So, electric field or electric field intensity, having said that, the definition of the force per unit charge is called electric field intensity. And what kind of force is this? And this is the force which we can say it's an electrostatic force of attraction or electrostatic force of repulsion between the charges. So that exerted force, we can also say that it's that particular force. And without that, we can also say that the force per unit charge is called electric field intensity. So electric field intensity, it's also a vector quantity. Its arrow mark also show us that it's a vector quantity. The SI unit of electric field intensity is Newton per coulomb. That's the SI unit. Another SI unit is volt per meter. Volt per meter is the another unit of electric field intensity. Here Q naught is the test charge on which we are working on. It serves to allow the electric force to be measured, but it's not a large enough to create a significant force on any charge. So particularly, the electric field, known as the electric field, we can calculate the force on any charge. So by arranging that how much a charge exerted by the electrical intensity feel the force, that particular formula can represent in this way. So if a charge is moving towards in this direction, the lines of forces can flow in this way. And if the charge is having another direction, having the magnitude in negative 9.30 macrocoulomb, then that particular direction of charge in this way. So the lines of forces of direction of force can be in this way. The direction of force depends on the sign of charge minus in the direction of the field for a positive charge is opposite it for a negative one. अब इसमें बताया ही जा रहा है कि पॉजिटिव चार्ज की जो फोर्स और इलेक्ट्रिक फील्ड की डायरेक्शन है वो एक डायरेक्शन जानिब होती है, जबकि नेगेटिव चार्ज की जो डायरेक्शन ऑफ फील्ड होती है वो फोर्स के मुकाबले में अपोजिट होती है. तो ये एक फैक्ट है जो कि इलेक्ट्रिक फील्ड और इलेक्ट्रिक फील्ड इंटेंसिटी के हवाले से बताया जा रहा है स्लाइड में. फर्दर वी मूविंग टुवर्ड्स द डायरेक्शन अबाउट ऑफ इलेक्ट्रिक फील्ड. The electric field of a point charge. Point charge is what? The point charge is, there are 2 to 3 names of that particular charge, that is Q of charge, electric charge, test charge, and also we can say it's a unit positive charge. So 2 to 3 names having the particular positive charge points readily away from a positive charge and towards a negative one. So it's moving from this one to the another direction of this one. So in 2D figure, in between the x and y axis, the radial distance covered by a particular charge of Q naught in this way towards the direction of electric field intensity in between x and y axis linearly. So this is and how we can observe the particular direction of a unit positive charge when it is readily away from the positive one towards the negative one. So another concept of electric field intensity, इसमें हम ये discuss करेंगे कि just as electric forces can be superposed electric field can as well. So you can say this one is the negative charge the electric lines of forces exerted towards that one and cover some kind of distance. The positive lines of forces can produce its lines of forces in this direction, and the net resultant vector of these two, even in E2 electric lines of forces vector, the net effect vector of that particular E lines of forces is moving towards from P point to E net. So we can say that the uh, resultant vector of electric lines of forces or electric field we can also find by this way. If we can get the multiple electric lines of forces having a certain direction. So it's also a linear graph which is made between the x and y axis, and the horizon of that graph is tells about the vector direction of electric field and resultant vector of electric field. So further we moving towards the next aspect of electric field lines, which are so electric field also called electric lines of forces and electric field lines. Electric field lines are a convenient way of visualizing the electric field. So electric field, it's a convenient way to visualize the electric field. Why visualize? Because it's a region horizon create around the particular charge. So that's the reason the visualization is most important aspect to understand the concept of electric field, electric lines of forces, and all the other aspects. More conveniently and concisely, you can understand these concepts in the coming slides in this way. So in next slide, you can say that the horizon and the emitting the glow of electric field, it looks like in this way and in this way. So first, before we understand the concept of these fields, start at positive charge or infinity. Positive charge or infinity, because the lines of forces are emitting from a particular static charge, static which is placed and not moving with some kind of velocity. So the lines of forces can emit from its particular region of charge and emitting its direction of forces in its region continuously. And at negative charges or infinity, so it ends at end means the collecting odd lines of forces in a particular point. That aspect is called the end at negative charge, or from the infinity we can say towards the infinity, are more dense where the field is longer. So it will be more dense when the field is too much stronger. So now this is the visualizing aspect of electric lines of forces uh, of the slide presentation. The charge on the right is twice the magnitude of the charge, and the left the opposite is in sign. So you can say that the this lines of forces of charge is in Q, and this is in minus Q2, minus 2Q. So what means tells that these lines of forces are limited and these are too much because the direction because the magnitude of this charge is twice. So if the magnitude of that charge is twice, then the lines of forces as compared to this one is also the twice, or you can say in large quantity. Up till now, any one of you, if have any kind of question, query, or difficulty, feel free to ask. I will answer the kind of question and resolve your queries if you have in your mind. Otherwise, I continue the session. So there are twice as many field lines. So you can already see that these are the lines of forces are too much because magnitude of charge is twice, and the point toward the charge rather than away from it. So the concept of dispersion and conversion, you can say that these lines of forces are dispersed, बिखर रही हैं, ये नमूदार हो रही हैं, glow कर रही हैं. These lines of forces from positive charge, and the negative twice charges are the lines of forces collecting on a single point, which are the electric field lines of forces, electric fields collecting, converging into a single point from the infinity or towards the infinity in this way. So these are the two opposite concepts from positive charge and negative charge. And also we can understand the concept, uh, the single entity charge and twice entity of charge, that lines of forces are too much higher as, uh, if the lines of if the charge is in single entity. Electric field lines, another concept, is the combination of charges. If the two charges are combined each other into a single region and near and far to each other. Note that while the lines are less dense, where the field is weaker, the field is not necessarily zero where there are no lines. In this fact, there is only one point within the figures below where the field is zero. And can you find it? So it's a really understandable thing that if the two charges are unlike in nature, that one is positive and another is negative, the lines of forces are collide, coincide with each other to interact, and you can say that they are mixing with each other. Someone is the donor, someone is the collector of the lines of forces, and in this way the lines of forces from positive charge collecting by the negative charge. Both the charges are in same magnitude but opposite in direction. Now moving towards the B figure. So in figure B, you can see that the positive unit positive charge is in 2 times and the negative test charge is in 1 time in magnitude. So the lines of forces of positive charge is too much higher as compared to the negative one. So the lines of forces are starting emerging from 2 times of q towards minus q of the charge. So it is starting its lines of forces and collecting or absorbed by the negative one. But if you look at to the point or figure C, you can see that the electric charges flow its lines of forces, which are the electric lines of field, electric lines of forces in this region, and the field, due to the like charges, that q1 is plus, another q1 is also a plus one. So both the lines of forces emitting its lines of field, but the net effect is zero because both are repelled to each other. The same concept which we discussed in our previous sessions of lecture 4 and 5 in Coulomb's law, the same scenario can be understandable by this figure C. Now, electric field lines, you can see that if two plates placed near to each other, one is the positive one and another one is negative one, both are placed having the distance d, and the lines of forces flow from positive charge plate to the negative charge plate in a sense of E, electric field intensity, electric lines of forces. So the flow of electric lines of forces from positive to negative, uh, in pictorial way you can see this thing. A parallel plate capacitor consists, so it's looks like a capacitor because two conducting plates separated by a distance of dielectric with each other, then the capacitance is created in between the plates. So this is the also a main concept of capacitor, reflect by this figure or diagram. So a parallel plate capacitor consists of two conducting plates with equal and opposite charges. Here is the electric field produced in that particular region in between the capacitive plates. Okay, now we discussed now we was discussed about the electric field lines. So further we are discussing about the solenoid concept of the lines of forces. So this is the spherical aspect of positive and negative test charge of surfaces. So since excess charges mean जब आपके पास वाफिर मिकदार में charges आ जाते हैं, on the conductor is free to move, the charge will move so that अब इससे पहले का जो सरफेस था हमारे पास वो एक स्ट्रेट स्ट्रिप्स ऑफ बार की सूरत में था, जिसके अंदर हमारे लाइंस ऑफ चार्जेस एक ही रीजन में रखे जाते थे, एक प्लेट की सूरत में। लेकिन जब सरफेस हमारा इस तरह स्फेयर की नेचर का होता है जिसके अंदर चार्ज आपके फ्रीली मूव कर सकते हैं, तो ये उसकी बात हो रही है दैट पर्टिकुलर ऑब्जेक्ट विल मूव सो दैट दे आर एज फार अपार्ट एज पॉसिबल, यानी वो उससे दूर दूर हो जाते हैं चार्जेस। दिस मीन्स दैट द एक्सेस चार्ज ऑन द कंडक्टर resides on its surface as an upper diagram. So you can say that वो अपने एड्जेस पे आ जाते हैं, इसके ऊपरी हिस्से पे आ जाते हैं अंदर की जानिब से। लेकिन अगर आप उसे दरमियान से देखें तो एक्सेस चार्ज आपको मल्टीपल यहाँ पे नजर आएंगे। So shielding and charge by induction. When the electric charges are at rest, the electric field within a conductor is zero. तो अगर आपका एक इलेक्ट्रिक चार्ज वो रेस्ट पोजीशन में रखा हुआ हो किसी रीजन में, तो इलेक्ट्रिक फील्ड उस कंडक्टर पे जीरो होगी, वो प्रोड्यूस नहीं होगी इलेक्ट्रिक फील्ड जो है एक कंडक्टर के अंदर। सो ये वही कॉन्सेप्ट है, ये इसको इस तरह समझें कि ये कंडक्टर है जिसके अंदर से ही आपकी इलेक्ट्रिक लाइंस ऑफ फोर्सेस आपकी एक तो प्रोड्यूस हो रही है, लेकिन कंडक्टर अगर रखा हुआ हो विद इन दैट पर्टिकुलर चार्ज तो आपकी इलेक्ट्रिक लाइंस ऑफ फोर्सेस प्रोड्यूस नहीं होगी। शील्डिंग एंड चार्ज बाय इंडक्शन। अब इस कॉन्सेप्ट को अगर हम समझें, द इलेक्ट्रिक फील्ड इज ऑलवेज परपेंडिकुलर टू द सरफेस ऑफ कंडक्टर इफ इट when the charge would move along the surface। तो फील्ड ऑफ लाइन इस तरह मौजूद है, तो आपका कंडक्टर अगर इसके दरम्यान रखा हुआ है तो लाइंस ऑफ फोर्सेस इस तरह से एक्ट करेंगी।